warahmatullahi wabarakatuh. Hello friends, how are you today? I hope we are in good health. As usual, before we start our lesson, let's pray together. Start. Enough. Before we continue to study, let's watch this video first. Okay guys, if you toss a coin as like this video, what is the chance you'll get a heads? Or if you roll a dice as like this video, what is the chance you'll get a 5? Or you might hear things like it may rain today, or it's highly likely that our team will win the football match. In all these events, there is some uncertainty, this randomness, because we are not sure of the result. And for this, we use the concept of probability. So it will be the topic of this video. Now, let's study about the probability with me. I'm Nabila Alfin from study number K1324006. I will give the concept really easy for you, and in this video, there are also exercises that you can do and answer with comments below.
Are you ready?
So, what will we learn today? First, we want to learn about the definition of probability. And the second is basic probability. The third is different type in probability. Now is the definition of probability. Probability is a way of measuring the chance of an event happening. The simple definition, isn't it? So next, to continue with K term of probability or the basic of probability. The first is random experiment. What is the random experiment? The random experiment is one in which all possible outcomes are known but cannot be predicted exactly in advance. For the example, when we tossing a coin, rolling a dice, when we tossing a coin, we know about the possible outcomes, but we cannot predict about the outcomes. And also, when we rolling a dice, we know about the possible outcome, but we cannot predict about the outcome. But when we boil water, it's not a random experiment. Why? Because when we boil the water, we know what will happen. That is, the water will evaporate, right? We know the output and easy to predict about the outcome. In random experiment, we cannot predict about the output. So, boil the water is not the random experiment. Earlier, I often mentioned about outcomes. So what is the definition of outcomes? An outcomes is any possible result of a probability experiment. The example of outcomes is the outcomes of tossing a coin are head and tail. And also getting 5 is an outcome when a die is rolled. For the next is a sample space. What is sample space? The sample space of an experiment is the set of possible outcomes of that experiment. The set of possible outcomes. For the example, the sample space of tossing 2 coins is head tail, tail head, and also tail tail. Now coming to the next definition, the definition of event. Event is the collection of some outcomes of the random experiment. We know a sample space of tossing a coin. There are head tail, tail head, and also tail tail. And an event of getting 2 head is head, just one possible. An event of getting 1 head, there are head tail and tail head. The first coin is head and the second coin is tail. Or it can be the first coin is tail and the second coin is head. Okay, now we learn about how to calculate the probability of an event. PE is number of favorable outcomes over the total number of outcomes. or we often write it PE is equals to NE over NS, where A is even, so NE is the number of elements in even, and also S is the total outcomes or sample space. So NS is the number of elements in sample space. Okay guys, now we try to answer the questions. The first question is, when we flip two coins, what is the probability of getting exactly one head? We know when we flip two coins, we can know the sample space are head head, head tail, tail head, and also tail tail. And then the number of the element in sample space, they are 1, 2, 3, 4. They are 4. And after that, the probability of getting exactly just one head. So here I can write the even one head, just head tail or tail head. So I can write here head tail and tail head. So the number of element in this event just 2. From that information, we can calculate about the probability. So I can write here the probability of an event is equals to NE over NS, where NE is the number of an element in event. I can write here 2 over NS, here the number of element in sample space. There are 4, or I can write here a half. So the probability of getting exactly one head when we flip two coins is a half. So guys, let's do the next example. When we roll a dice while playing snakes and ladders, what is the probability of getting a 5? When we roll a dice, we know the sample space are 1, 2, 3, 4, 5, and also 6. So the number of elements in sample space is 6. After that, the probability of getting a 5. So I can write here the even is 5. So the number of elements in this even just 1. From that information, we can calculate about the probability of an even. So I can write here the probability of an even is equals to NE over NS. NE is 1, and after that NS is 6. So the probability of getting a 5 when we roll a dice is 1 over 6. It is very easy, isn't it? Okay, let's do the next example. In the deck of cards, what is the probability of getting a spade? We know in the deck of cards there are 4 types of cards. There are heart, spade, club, and also diamond. And I can write here a deck of cards. There are spade, and then heart, diamond, and also club. And the number of each card, there are 13. So there are 13 cards of spade, and then 13 cards of heart, and also 13 cards of diamond, and then 13 cards of clubs. When I sum all of the number, there are 52 cards, and this 52 cards is the number of element in sample space, the total of the card. From that information, we can calculate about the probability of even. We can know about the even is paid. So the even is equals to 13 because there are 13 cards in the deck of cards. 13 cards of spade in the deck of cards. So here we can calculate about the probability of an event is equals to NE over NS, where NE is 13 and then NS is 52, or I can write 1 over 4. So the probability of getting a spade from the deck of cards is 1 over 4. Now, let's continue with the different type of events. There are complementary events, mutually exclusive events, exhaustive event, and independence event. But in this video, I just tell to you about the complementary event and also mutually exclusive event. For the other, maybe we can discuss it in the next video. The first is complementary event. The complementary event is outcome in the sample space they are not part of an event. The formula is PA plus PA complement equals to 1, or PA complement is equals to 1 minus PA. For the example, in the experiment of throwing a dice, what is the probability not getting 5? So, we know about the number of elements in sample space is 6. Number of elements in event is 1. So we can know about the probability of event is 1 over 6. From this, we can calculate about the PE complement is equals to 1 minus PE. So 1 minus 1 over 6. And then the answer is 5 over 6. Okay guys, let's to answer about the question in complementary event. In the deck of cards, what is the probability of not getting a king? Remember about the deck of cards, there are 13 cards of spade, 13 cards of hearts, 13 cards of diamond, and also 13 cards of club. And of 13 cards, each has one king card. I can write here from 13 cards, each has one king card. One king card, just one king card, just one, and also just one. So the total king cards from a deck of cards, there are 4. So if we want to know about the probability not getting a king, the first we have to calculate about the probability of that event first. So the probability of that event is NE over NS. NE is 4 and also NS is 52, or I can write here 1 over 13. After that, not getting a king, so the probability of even complement. The probability of an even complement is 1 minus the probability of even. 1 minus 1 over 13, and then 13 over 13 minus 1 over 13. So we get 12 over 13. For the next, we study about the mutually exclusive event. Is events that could not happen at the same time, because the events could not happen at the same time, so the probability A and B is equals to 0. So we can know the formula of mutually exclusive event is probability A union B is equals to PA plus PB minus P, A and B. We have the probability A and B is equals to 0, so we can write that PA plus PB minus 0. So the probability A union B is equals to PA plus PB. For the example, when we roll a dice, find the probability of getting even number or odd number less than 5. We know about the number of elements in sample space are 6. And even of A, dice should show up even number. Even of A is 2, 4, and 6. And even A is equals to 3. And then even of B, they should show up odd number less than 5. So AB is 1 and 3. So and even B is equals to 2. It is the Venn diagram about this mutually exclusive where A and B is disjoint sets. So the probability of A union B is equals to PA plus PB. So 3 over 6 plus 2 over 6. So we get 5 over 6. So the probability of even number or odd number less than 5 is equals to 5 over 6. Okay guys, now we want to answer about the question in mutually exclusive, and the question is, what is the probability of getting king card or jack card? We know in the deck of cards, the sample space in deck of card, the element in sample space, there are 52. And then from previous questions, we know about the number of king cards. There are 4. And it's same with the jack of cards. There are 4 too, because each type of card from the deck of card, each has 1. So the total is 4, and also the king card is also 4. For example, if I make a king card is even A, so an A is 4, and then N B is also 4. When in mutually exclusive event, the probability A and B is equals to 0. So the formula, the probability of A union B is equals to PA plus PB minus PA and B. Because of the probability of E and B is equals to 0, we can write here is 0. PA plus PB. So the formula is PA plus PB. And after that, we know PA is an A over an S, and also PB is an P over an S. And E is 4. So I can write here 4 over 52, and then NP is also 4 over 52. So I can write here 4 over 52 plus 4 over 52 is equals to 8 over 52, or it's same with 2 over 13. So the probability of getting king card or jack card is 2 over 13. Okay guys, this is the exercise, so don't forget to do it and write the answer in the comment below. Okay guys, this is enough for me, and if I have any mistakes, I apologize to you all. Thank you for your attention, and wassalamualaikum warahmatullahi wabarakatuh. See you guys.